Okay, so you should have watched the overview video so you know what's going on. We're going to start talking about intermolecular forces. So we go into our learning target. I can explain intermolecular forces between covalent compounds. I can explain how intermolecular forces affect the properties of covalent compounds. So we're looking at intermolecular forces, the forces between molecules, in particular for covalent compounds, and then we're looking at what they tell us about the properties of covalent molecules. So we have our vocabulary. So you guys are going to be, some of this is review, right? Polar molecules, nonpolar molecules, polar bonds, lone pair electrons, right? So our forces are going to be dispersion forces, hydrogen bonds, and then dipole interactions. They're also called van der Waals. Then there's van der Waals forces, there's volatility, melting points, boiling points, viscosity. So it's all going to come in. So let's get started. We'll start with the first, which are dispersion forces. They also call them London dispersion forces. This is the weakest. All right, and so this is going to be between non-polar covalent molecules. So remember, non-polar covalent molecules, if we look at the difference in electronegativity, it's very small, or 0. So it's less than 0.4 if we take two atoms and subtract them. And what's happening is there's a temporary dipole that gets created, and a dipole means one end is slightly positive and one end is slightly negative. And how does that happen in a nonpolar covalent molecule? Because that means the electrons are basically being shared equally. So the way that happens is the electrons are actually moving, right? They're in orbitals. So while they are being shared pretty much equally, they're still moving around. And so temporarily, you could find a buildup of electrons on one end of a molecule over another. So if we had a molecule of hydrogen, which is H2, right? They're held together by this bond. It's non-polar covalent because the electronegativity difference is 0. So you have this temporary partial negative, partial positive as the electrons are moving around. And so these molecules will orient themselves based on those charges. So the partial negative and partial positive here are together. But then you can imagine a situation where they shift, right? The electrons then move back, these guys repel, but maybe there's another molecule here that drops in. So they're sort of being held together, but it's a very weak force, the weakest of those three. And so think about it in terms of a tug of war. So if I got a guy here, right, and he's pretty equally matched with this other guy, and they're going to have a tug of war, right? I'm drawing this guy a little bigger, but say they're about the same size, same strength. They've got a rope in between them. There's a little flag here so we know who's winning, right? At one point in time, this guy may plant his feet and pull a little bit harder, and the rope is going to go a little closer to this side. As soon as he feels that, he's going to pull a little bit harder in his direction. So while they're equally matched, this rope could be moving closer to one side than the other at various points in time. And it's the same idea here with those hydrogen atoms. Okay, so remember, non-polar covalent, right? Temporary partial positive, partial negative. All right, weak attraction. This is it's clear, it's temporary dipole, right? So that's how we can think about those.